welcome everyone. I'm Daniël Spee, work at Luminous as a software and search engineer. And for the past couple of years, I've worked at a big company in the legal domain, and working there on a big search project. So I want to share an experience which I had while working on that project. It's called So Many Results, Give Them to Me. Usually when you do a search project, you give the most relevant results to your users, like the first 25 or first 50. But in some use cases, you will not want just the first 25 or first 50, but you want them all. You want to do some analytics, or you want to do export or something like that. And that's what my experience will be about, what I'm going to tell about. Welcome, everyone. Please have a seat. So to give a little bit of context, turn on my pointer. We have a search application, cool front end, and then a search service below that, and an Elasticsearch cluster. Very large data set, as you can see. It's about 150 million full text documents, really big documents. It has about 140 nodes and 140 terabytes of data. So about a year ago, we decided to want to go to the cloud. So as you can imagine, with such a large cluster, very cool in the cloud, but costs a lot of money. It's around $30,000 a month. So we're fine with that. But then we started to look around the product landscape. And we saw that we had some similar projects which use similar data. So there was a very cool analytics application. Kind of looked like the same. They had also a search service. Elastic Cluster uses exactly the same data. So this one was not in the cloud yet, so we also wanted to move it to the cloud. But as you can imagine, when you want to do both of those clusters in the cloud, it can be very, very expensive. Like I said, $30,000 a month. And if you want to do it twice, then it will be $60,000 a month. And if you have more applications, it can build up pretty fast. And as they also share similar features with the search, we told Mike, okay, let's just merge them together. Let the analytics application use the search of our search application, because the search application also has a broader variety of features which they also can use. So ditch the cluster and the search services, and move just the cool front end to the cloud, and let's use the search service. But turned out it wasn't that easy. We didn't have the features to support them yet, because they, as I said, they're an analytics application, and they would not want a few applications like pagination, but they want like the whole bunch of results. So we started to look, and how should we implement it. We couldn't use their code because it was in another language and different Elasticsearch version. So we had to build something new or add new features to our current search service. So I'm going to tell you a bit about the Elasticsearch ways to get all the results from Elasticsearch. Elasticsearch is bound by a limit of 10,000 results. It looks a bit weird, but it's okay. You're bound by 10,000 results you can get when you do a normal search with pagination. And of course, you can increase this cool limit, but please never do that, because it can blow up your cluster because of performance and stuff like that. So please do not do that. Used to be the preferred way, but not anymore, was the scroll API from Elasticsearch. With the scroll API, you can get more than 10,000. Still, you are bound to 10,000 results per request. But you can do multiple requests after each other within your scroll API and the scroll context, to get all the results from your query. Used to be the preferred way, but not anymore. They have introduced search after, and it's pretty cool. You can just use the sort values of your results, and then move to the next window for for the results you want. Gonna explain a bit more about scroll API and search after. Yeah, the scroll API used to be the preferred way. It creates a scroll context on each request, and it also has a feature called slicing, which you can use to divide requests so that you can do parallel requests, and requests like 10,000 for each parallel request, so you can get more at the same time. Downside from this is that for each request you do, you get a new scroll context, and scroll context take up resources in Elasticsearch cluster. So that's why they wanted to do something new, and it's called the search after. It's just a property in your query, and then you have to use the sort values from your previous request in the new request, and to get the next couple of results. At the time of our merge, we were at version 7.11 of Elasticsearch, and in 7.10 they introduced point in time, so that was very good. It's very similar to scroll context. Scroll context is where you keep the state of your result set intact, so updates and deletes will not affect your result set. Point in time is very similar, except that you can share your point in time scroll context with other requests. So you can use only one scroll context for multiple requests. Saves a lot of resources in your Elastic cluster. So that's very cool. But it didn't have slicing yet because we were only at 7.11, and apparently slicing was only there for 7.15. So we also needed to upgrade our Elasticsearch cluster, which was also a thing on itself. Always cool to find new things and new features, but also sort of problems which could arise. But luckily, we didn't have much problems, so we could easily migrate to a higher Elastic version and use the slicing part of the point in time. So a bit more about slicing. As you can see here, you have one request, but instead of one request, you make it multiple requests at the same time to Elasticsearch. So when you get all those results, how do you send them to your client? We explored a couple of options. Could save it to the file, or we could use some queuing mechanism, or use a streaming option. And we explored some of those things, and we were like, okay, why are we now exploring now? Maybe we should understand better what the application that you're going to use our service, what does it want? How do the users use this application? So do we need sync or async? And apparently it is so that even though they want a lot of results, some users still have a use case that they actually wait for the results, so they want sort of immediate result. The timing of that is not really shouldn't be like in milliseconds or something, but could take up to a minute. That's okay for the users because that's just how it works with lots of data. So we turned out to use a streaming variant. To be specific, we used streaming response body of the Spring framework, which turned out to be really useful and really good for a use case. Right. So the importance of performance test. When we merge our two services together, you want to make sure that everything still works, because now there's one service who want to get many results, and how is that going to impact our search service? So you have to have your performance test ready for at least your search service, and you simulate your user load, and that's what we also did. We simulated our average user load and also the peak load to see if it can handle all the stuff. And then next to that, you also have, of course, your analytics side of the queries. It's also really important to combine those together to see if your cluster and your services can handle everything. So please do not forget to merge all your performance tests and put them all together and see if your environment can still handle everything. So while we did that, we came to the conclusion that it's not fast enough. It's very slow because of all the big requests, the big queries they use from the analytics side. It really got us really slow. So we were going to investigate a bit on why is it so slow? Why is it slow? Is it Elasticsearch? Is it our servers? So we came to the conclusion that we had some issues with threads and connections. Well, as I explained before, slicing, it splits your request into multiple requests to Elasticsearch, so you can get multiple results in parallel. But for each slice, we actually created a new thread, and each thread also has a separate connection to Elasticsearch. So what happens if you get lots of requests, you get lots of threads, lots of connections to Elasticsearch. Yeah, that results in lots of threads, lots of connections. So please keep in mind that you have to tweak your thread pools and also your connections, because Spring has I think a basic limit of 200 connections. So you have to tweak that a bit to see what happens, and we also did that. And we got some good results. Some queries were working very well, but there are queries with very large result sets, in the millions actually, and they turned still out to be very slow again. So we had to do some more, and that's scaling the environment. So we did some virtual scaling. We added more CPUs because there were a lot more threads used, and I think we made the instances twice as big in CPU-wise. So that already helped a lot, and got very fast. While we were also testing, we also explored the option to increase our charge size, because the recommended charge size is about 40-50 gigabytes for Elasticsearch to get fast responses from Elasticsearch, but we try to get to a bigger shard sizes. I think we went for 100 gigabytes, and performance tests, they turned out to be still pretty well, actually good enough to continue with our project. Next to that, we also did some horizontal scaling, so we increased the number of search instances, because many threads in your application, so it's useful to get more search service instances, also with the bigger amount of CPUs, so they can handle all the threads as they're supposed to. So the conclusion is, we got it working in the time that they that they wanted to. Like I said, it could be up to a minute that a user expects results. So the first thing is we saved a lot of money, because we were going to move to the cloud. Now we don't have multiple clusters in the cloud, just one cluster to use. There's also the maintenance to the search and adding new features, because when we add new features, if you want in both applications, in the previous way you have to do it in both sides, and now we have just one cluster and one search service to maintain. And saves a lot of time as well to implement features and improvements. Yeah, next to that, what I just said is, still the timing is really good for our queries and results. So we're glad that we did this. Thank you all for listening. Are there any questions? I think we have some time left. 2 minutes. Any questions? Yes.
Can you merge them, but then you scale them up? So didn't you scale it up to twice the size?
No. That's a good question, actually. I didn't know if anyone can hear it, but he said we scaled up the environment. Did we increase it to twice as much? No, that was not the case. I think we only added a couple of instances. We left the amount of Elasticsearch nodes the same, so that was actually the same amount. And we increased a couple of search services instances, but that's about it. So, there was a cost increase by using larger instances for CPUs, but wasn't that significant compared to two different clusters. Yes.
So how did you determine the bottleneck? Like the application on top of the ES?
Yes.
Like how did you? But how were you able to do that? To find the bottleneck?
Yeah, just
The
application monitoring. Yeah, just application monitoring. We could see that that our bottleneck was in the search application actually with the threads and connections. Yeah, so that hope that answers your question. All right. Any more? All right. Thank you all for listening, and I'm gonna pass the ball to the next speaker.